Right at the right point when I take my jacket off and throw it into the crowd, we'll cue the music. My name is Dustin Kirkland. I'm going to be assisted today in this presentation by Alessandro Pilati. Sorry. It's been a long day. I apologize already. That's setting the tone here. We're talking about guests in Ubuntu OpenStack. A key theme of infrastructure as a service is that guests are what make the compute portion of infrastructure as a service interesting. And it's a variety of guests that keep it interesting. If you've been to a house party, probably with that music playing right there, and everyone is exactly the same in that house party, it's no fun whatsoever. Who wants to go to that party? You want to go to the party that has all sorts of crazy guests. That's a good party. And in fact, in the data center, if you're looking at a real-world data center, there is quite a bit of variety. There's no such thing as a 100% homogeneous environment in a data center. So let me ask you, as soon as I find my mouse, and I click to the next screen. Hello. Let me ask you a question. Who here is staying in an apartment or a bed and breakfast? Mr. Baker is Airbnb? Yep. Anyone else? It's great. It's such a disruptive model, that Airbnb, that home away style of put your house up for rent. You rent a house instead of staying in a hotel. But if you're not in a B&B or an apartment, you're probably in a hotel, right? Anyone here in a hotel, right? Okay, excellent. We're guests in this town, just like guests in an OpenStack. Vancouver's fantastic. I took a seaplane tour last night. If you haven't done that already, I highly, highly recommend it. When you booked your hotel accommodations, most people booked a hotel, what information did you provide? Very basic information, right? Billing information, right? You had to provide a name, the dates that you were going to stay, how long you were going to stay, maybe how many people were going to stay, and most importantly, a credit card number, right? But it was just basic information, right? You didn't have to provide what you're doing in town or what you're doing in that accommodation. That's your own business. You're using that apartment or that hotel as infrastructure. Now, if something goes wrong in that hotel or that apartment, and you call the landlord or the owner or the lobby, the front desk, basic hot water has gone out or the electricity has gone out, you would expect support from your host, right? That's a basic guarantee. That's part of what you're paying for. And hotels, apartments, that's classic. That is the most classic example of infrastructure as a service. The brick and mortar infrastructure as a service has been around since Roman times, in fact. The first documented apartments were actually in Rome. And that hot water is going to get fixed regardless of your personal background or your brand allegiance, that you normally stay in Hilton, but you're in a Marriott this time. The who you are should never be part of the equation when you're obtaining support from your infrastructure provider. What you're doing inside of that guest is very separate from that infrastructure provider. And that's exactly how we operate in Ubuntu OpenStack. We have a very open platform, in fact, and we're very accepting of all guests. All guests, all types. Anyone recognize this sign? This is a classic sign from the 1950s. This actually, the sign, if you look up the history of the sign, it comes from the Amish culture. As the Amish were building their own handmade furniture and so forth, many people didn't realize that their wares, their goods were available for sale to non-Amish people, and so this very iconic sign was created in the 1950s. In fact, real clouds, you're going to find every type of guest in the world in there. Hopefully you see a lot of Ubuntu. That's part of my job, to convince you to run a lot of Ubuntu. But again, in the real world, there's CentOS, there's Oracle Linux, there's Red Hat, there's SUSE, there's Debian, there's Windows, and lots more, in fact. And it's full virtualization that makes that possible. We've talked in this room today, yesterday, and the day before quite a bit about Linux containers. and why LexD is such an incredible technology for packing incredible density, high density guests into one system, something like 14 times as many. But that's not to say that containers are a complete replacement in all cases for virtualization. Full virtualization, KVM, still has some very important advantages, the most important of which, I think, are the limitless possibilities of what you can do in that container. It is an emulation of a full hardware platform. And perhaps the best example of that right now is Windows as a guest, and Alessandro is going to talk to us a little bit about that.
Thanks, Dustin.
Mm-hmm.
So my company, Cloud-Based Solutions, is responsible for quite a lot of work that we did together with Canonical and with the Ubuntu community. Actually, we are extremely pleased about what we did in the last 2 years. So the result has been published this week. Actually, on Monday, we went live with a big series of, with a big catalog of Juju charms, okay, that cover a very, very large amount of typical Microsoft workloads, which I'm now going to introduce to you. So first, the first thing that we did with the OpenStack community was porting actually the support of Nova Compute to Hyper-V. So we have full Hyper-V integration. What we always looked for was to find ways in which we could also ease up the integration of these new Hyper-V compute nodes into full OpenStack cloud, okay? Juju and Mass provide an amazing way to do this. So the first thing that we did was obviously to create a charm specific for Nova Compute on Hyper-V, which is integrating all of our open source work that we did, okay, together with all the great deployment options that Juju can give you. Here's actually how it looks like. So if you guys are familiar with the Juju GUI, actually this is really a killer feature. I mean, there is no other deployment solution that can offer something like this. I mean, something in which you can really, really visually see what's going on. I mean, if you're really a hardcore DevOps, I mean, you don't need, of course, a graphical user interface for this, okay? You can just go in a command line shell and do everything, okay? So obviously you can use Puppet, Chef, whatever tools you want to do it, or obviously you can also use Juju on the command line. That's what you need anyway for more complex scenarios. But there is nothing like this view to explain very clearly how your OpenStack deployment works. So this is basically the plain vanilla OpenStack charm bundle, so the one that you can use with KVM and so on. Very important, we include here not only Hyper-V compute nodes, but also KVM compute nodes, okay? You have both of them included. On the top of this view, you can see that you have a failover cluster, you have an SMB file server, and you have a Windows Cinder charm, okay? So this is actually saying that the Windows Cinder charm that we have here is using a full scale-out failover cluster, okay, that provides a great degree of fault tolerance and load balancing for storage. I mean, using Microsoft technologies. This is actually one of the best practices that you can use for Hyper-V. Under it, you can see a very common component in every Microsoft infrastructure, which is an Active Directory domain. Active Directory domain controller. All those charms scale out automatically in the moment in which you increase the number of nodes. So it's totally and absolutely transparent for you. All the relationships between the charms do all the magic. For example, when you tie a Cinder charm to Active Directory or the Nova Hyper-V charm that you see under Active Directory, they will be automatically joined to the domain, and all the credential, authentication, authorization, and so on will be automatically handled. For example, the presence of that domain controller over there allows actually Hyper-V to perform live migration in a transparent way. So Hyper-V, for example, is the hypervisor in OpenStack that offers the most probably the easiest way to handle live migration. It's really transparent, easy, zero configuration issues, especially when done together with something like Juju, which hides, let's say, all the complicated configuration options that the operating system requires behind this. Okay. Next. So a thing that we really like about Juju is that we can use it to deploy the actual OpenStack, but we can also use it to deploy the workloads on top of it, you know? It's just one single technology to rule them all. It's amazing. In particular, in terms of workloads, we have all the main Microsoft type workloads here. Okay, not only in these slides. I mean, there are simply too many to be put on a single slide, okay? Here we have some of the most important ones. For example, SMB, which is actually how we call the charm for the file server, which is using the SMB3 protocol. Windows Server 2012 R2, which is here as a placeholder for VDI. VDI is an excellent use case in OpenStack and works extremely well when used together with remote effects, which is a feature coming in Hyper-V. Then you have Exchange, SharePoint Server, SQL Server. SQL Server in particular comes in two flavors here. SQL Server Express, which is free for everybody, okay? The SQL Server Express itself is free, not only the charm. And then you have SQL Server Always On, which is a full-fledged cluster, okay? Fully fault-tolerant, high availability, scalable, and so on, which is also completely deployed via our charms. Here is an example of a deployment in which you can see the SQL Server, Active Directory, and a failover cluster. The failover cluster uses also SMB for handling the quorum, when you need actually an odd number of nodes, or actually an odd number of voters. So complex technology requirement made extremely easy thanks to Juju. Okay, next. Now for something completely different. We don't support only Windows, but we support also CentOS. So we contributed CentOS support to Juju. We are big friends with the CentOS community, and we believe actually that Juju is a great tool that has to work on as many platforms as possible. So after working on the Windows part, we decided to contribute also CentOS. Actually, this is something that merged no more than 3 weeks ago. And it's ready to be used. So we have already some charms developed for it. So glad to see where the community will bring it from here. Okay, all these goodies are available on the charm store and also at cloudbase.it/Juju. Okay.
Thanks, Alessandro. Yep. So the other new guest that we wanted to talk about a little bit here today is something called Snappy Ubuntu, Snappy Ubuntu Core. Snappy Ubuntu is a new way of thinking about, a new way of using the same Ubuntu that hopefully you're well familiar with. It's binary for binary, hash for hash, the same compiled binary code as traditional Ubuntu, but it's rolled together and deployed and updated in a different way. Transactionally. Transactional updates are so important in a modern cloud world, and especially on embedded devices and smart appliances. So when we talk about Snappy Ubuntu, it's Ubuntu, but the way that the system boots and updates is done in this atomic transactional manner. And the way that actually works is through something called A and B, AB partitions, AB versions, AB versioning. So in a Snappy system, and the Snappy can run as a guest in OpenStack. That's obviously why I'm talking about it right now, as well as other public clouds and on bare metal, like a Raspberry Pi or something like that. And in all of those cases, the root disk is carved up into multiple partitions. There's always an A partition and a B partition for the root operating system, as well as another partition for applications and read-write space. So the A and the B partition are actually contain the kernel and the OS. They're mounted at runtime in a read-only manner so that no application, no administrator can even tamper with the root file system, okay? And that's done for security and reliability and a number of different reasons. Anything that you need to write and modify, any configuration information, is actually put over in the read-write space on the side. Now, we call these bundles of software on a Snappy system snaps. So there's a kernel snap, and that includes, of course, the Linux kernel and any other key information that we need to boot the system. Okay, so typically what you would normally think of as in/boot. The operating system, the rest of the user space OS, is handled in another snap. Okay, that's the OS snap, and then on top of that sit one-to-many application snaps, app snaps. Each of those app snaps we'll get to in a second, but the key point is that the kernel and the OS are those are the primary pieces that are provided by Canonical along with Ubuntu, and then every time a snappy system runs, it's running out of either the A or the B partition, and in that read-only manner. Now, it's running off of one of those two partitions. The other partition is actually the target for the next update. So when the next update comes, and that happens in the background while the system is doing whatever it does, right? Maybe it's a web server, maybe it's a refrigerator. But while that system is doing what it's supposed to do, updates might come down in the background, and they get written out directly to the other partition, the one you're not running in. And then at an opportune moment, that system, on the very next reboot, it will boot from the other partition, which will be your update. And the update happens atomically and as a transaction. If for some reason that boot does not fail, we can roll back that transaction, right? And we boot from the previous partition, which was known good and working before, and the next update will actually happen to the other partition. We do the exact same thing with apps. So apps are stored, whereas the OS we only store an A and a B, a 1 and a 2. Apps we store multiple to many. You can configure how many different versions of the app you want. You can always roll back to a previous version of that app, if you need it to roll back apps, or you can purge some of the unneeded ones. Snappy is minimal. It's the smallest Ubuntu that we've ever created. It's we call it Snappy Ubuntu Core because it's built on the core packages. Core is a special designation in Ubuntu for basically the most minimal system that we can still call Ubuntu. We can still support as Ubuntu. Our goal with Snappy is not to create as we do with say the Ubuntu server that you find in the cloud or the Ubuntu desktop, which is it's a small but broad set of packages that we find useful and most administrators might expect to find on a system. Snappy, on the other hand, is intended to create the smallest, corest set of features, of functionality that you need to then build on top of anything else you want. We're finding that to be an emerging trend and a fantastic best practice in the appliance space and in the microservice space in the cloud. So here's just sort of a comparison of what traditional Ubuntu and what Snappy Ubuntu might look like. And traditional Ubuntu, the Debian-based Ubuntu, the Ubuntu you're probably running in your cloud or on your laptop, we've got a number of problems. One of which is that basically any package can write to any file on the system. Discretionary access controls mitigate that a little bit, right? But applications that might run as root can overwrite any other application's data as root on that system, and it makes for a mess. It makes for very difficult, painful upgrades. And while we've done, I think, a pretty good job of keeping Ubuntu LTS after LTS after LTS being able to upgrade, surely you've hit some situation on some server somewhere where an upgrade failed, and then you've got multiple packages in inconsistent states, and it's difficult, if not impossible, to actually roll that system back to a usable state. In the Snappy world, it's a much more crisply delineated set of interaction points between the kernel and the OS and the apps that sit on top. So this is sort of a pretty rudimentary diagram, but I think a fair diagram of what Snappy looks like. So there's that kernel snap at the bottom and any kernel config that might be required to boot a system. The OS is a little bit bigger. It's a little bit more than the kernel, but it's actually pretty small. And then the OS might have some writable files it needs. It has to write etc network interfaces, for instance, and some other configuration. But it's very easy to see and to identify what's writable at that point. And then there are apps that sit on top of that, and each individual app has its own writable data. Snappy is also the most secure version of Ubuntu that we've ever created. Not to disparage traditional Ubuntu, but the way Snappy is architected, apps themselves are isolated. They're contained and they're isolated. And so we can use We can use Docker. We can use Linux containers, LXC, LXD. That's one of the best practices around containing apps. You can even put apps inside of virtual machines, inside of KVM, for instance. Individual snaps have their own writable area, and only that app can write to that writable area, in fact. And in doing that, we really ensure that apps are contained and isolated. Snappy is freely available. You can download it right now. There's 64-bit Intel versions. There's 32-bit ARM versions. We have more architectures coming online soon. You can run it on physical hardware. You can put it on a BeagleBone or a Raspberry Pi or a Panda board or a whole slew of little small devices, or even Intel devices and Intel NUC. But this is the OpenStack crowd. You certainly also can run Snappy in any OpenStack public cloud or private cloud. And it's a great way to get started and to understand this sort of new way of thinking about operating systems in a way that come 1604 Ubuntu. I think you'll find a number of production web services, and there's already devices being produced with Snappy Ubuntu on it. So, from myself at Canonical working on Ubuntu, and speaking on behalf of Alessandro and Cloudbase, come in, we're open, we're very fortunate to have users like you, and we're at your service.